Welcome. In section 1.5, we will review solving equations. We're going to review a few different types of equations. Most of these you should have learned about in a previous course. We'll talk about linear equations, which are also known as first-degree equations. Also, we will look at quadratic equations or second-degree equations. In addition, we will look at equations involving fractions, radicals, absolute value, and higher powers. Although I do plan to talk about many of the basic techniques involved in solving equations, there will be an assumption that you know a lot of basic algebra. Let's go ahead and look at our first example. In this example, we have a linear equation, and we know it's linear because each of the variables x here and also the x here are raised to the first power. So we should know that when solving equations like these, first thing we need to do is go ahead and remove parentheses. So we will distribute each of these. And so here we get 5x minus 15 plus 2x minus 7 is equal to 4, and then negative 3 times x is negative 3x, and negative 3 times 8 is negative 24. In our next step, we're going to combine like terms. So on the left-hand side, we have 5x plus 2x. Those combine together to give us 7x. We also have negative 15 and negative 7, which give us negative 22. And on the left-hand side, we have positive 4 minus 24, which is negative 20. And so that gives us negative 3x minus 20. Then, of course, what we need to do is get all of our x's on one side of the equation. So I'm going to add 3x to both sides. And we also want to get the numbers on the other side of the equation. So I will add 22 to both sides. And of course, what this does here is it cancels these terms, and it cancels these terms. And we end up with 10x is equal to 2. And finally, we can divide by 10. And that gives us x is equal to 2/10. And 2/10, of course, reduces to 1/5. Now, the decimal answer for this, of course, is x is equal to 0.2. And there will be times in this course when you'll be required to give a decimal answer, but mostly we are concerned with giving exact non-decimal answers. So the priority is to give our answers in a non-decimal format unless you are explicitly asked to do so. Let's take a look at another problem. Here we have a second degree or a quadratic equation. And we should remember that when solving a quadratic equation, we want it to be equal to 0. So our first step is we are going to subtract 15 from both sides, or you can think of it as we're going to move this 15 over to the left-hand side. In either case, we end up getting 8x squared minus 14x minus 15 is equal to 0. Now, once you have it set equal to 0, the technique that we use is factoring. Now, this is where I could spend a lot of time explaining to you how to factor. All of us should have some experience factoring. I will show you one technique that seems to be pretty effective. So what I like to do here is just make a little x, and then I'm going to multiply the numbers 8 and negative 15. And if you multiply those, you get negative 120. And then the middle number, the negative 14 here, I'm just going to write that down. And then we are looking for two numbers, here and here, such that the product of those two numbers has to be negative 120, and the sum of those two numbers has to be negative 14. So we need to think about what numbers can we multiply to get negative 120 and add to get negative 14. Now, negative 120 has a lot of factors, but the ones that are going to work here are going to be negative 20 multiplied by positive 6. Because when you multiply those, you get negative 120, and if you add those, you're going to get negative 14. So those two magic numbers are negative 20 and positive 6. Please excuse the background noise. Okay, and now in the next step, what we do is we're going to create a couple of sets of parentheses here. And I'm going to put x here and x here. And then those two numbers, so negative 20 and positive 6, I'm going to write those down. And then what I need to do is I need to divide each of those numbers by the leading coefficient. So I have to divide by 8. So I need to divide the 20 by 8, and I need to divide the 6 by 8. Now what you're going to do is go ahead and perform that division to the best that you can. So if all you can do is simplify, then you go ahead and simplify. So this is going to be x minus 5 over 2, and this will be x plus 3 over 4. And then the final step to this little trick is now you take this denominator and you bring it back in front of the x here. And that is going to give us 2x minus 5 multiplied by 4x plus 3 is equal to 0. And this method works. And of course, you can take some time and multiply this out to double check to make sure that it gives us the trinomial that we had to start with here, but this is the correct factorization. One thing I should say is that the only way this method is going to work is you need to make sure that there is no greatest common factor, which I did not mention at the beginning. So if there had been a greatest common factor here, you would need to factor that number out first, okay? Now, of course, once you have this in factored form, we know that all we have to do is set each of these factors equal to 0. So 2x minus 5 equals 0, 4x plus 3 equals 0, and then you simply solve each of these simple linear equations, and we get our two answers. All right, let's try another one. So in the next equation, what we have here is what is called a rational equation. We have fractions, and in particular, we have variables in the denominator of the fraction. The first step is to go ahead and factor each of the denominators. And so you notice the first two denominators are already factored. And so there's nothing we need to do with x minus 2 and nothing we need to do with x plus 2. But in the final term here, x squared minus 4 does factor as a difference of two squares. We can write that like x minus 2 times x plus 2. The second step is to identify the least common denominator, and the least common denominator is x minus 2 times x plus 2. And what we're going to do now is we're going to multiply both sides of the equation by that least common denominator. Now on the left-hand side, when we multiply, the x minus 2 cancels out, and we end up getting x plus 2 times x plus 5. And on the right-hand side, we have to distribute this to each of these terms. And when you do that, in the first term here, the x plus 2 will cancel out. So we'll end up just multiplying x minus 2 times 5. And in the second term, you can see that both of these factors are going to cancel out. So we will end up just getting plus 28. So what we've done is we have removed the fractions, and now we can go ahead and remove the parentheses. So I'm going to multiply out these two binomials here, which I'm sure you all know how to do. I'm going to multiply out the parentheses on the right-hand side. Now, of course, on the right-hand side, negative 10 plus 28 is positive 18. And now you can see we have a quadratic equation, and what we need to do is set that equal to 0. And when we do that, we get x squared plus 2x minus 8 equals 0. And from there we can factor, and I would say this factorization is relatively simple. I think most people can do this one in their heads. Reason for this is because we have a 1 in front of our x squared, and so it's pretty simple to find two numbers that multiply to give us negative 8 and add to give us positive 2. And finally, we set each one of these equal to 0 to get our two answers, negative 4 and positive 2. However, when you're solving a rational equation, you always have to go back to the beginning to check your answers. So I want you to notice that the answer x equals 2 is actually not an answer, because if you plug x equals 2 in here, you will be dividing by 0. So we have to exclude that from our answer. So as it turns out, our only answer is negative 4. So any number that makes the denominator equal 0 cannot be an answer. That's what we call an extraneous solution. All right, let's try another one. So here we have another quadratic equation, but if you look at these numbers, this is not going to factor. And you can try, so we can make our x, we can multiply 2 times 1, and then put our middle number in there. And then you have to think, what are two numbers that you can multiply to give you 2 and add to give you 8? And there are no such numbers. Or at least there are no such whole numbers that we can do this with. So to solve this equation, what we're going to do is use the quadratic formula. So I'll go ahead and put that here. So the quadratic formula is this formula here, and we use it to solve a quadratic equation, and make sure that when you're solving your quadratic equation that it's equal to 0. So for us, we need to identify a, b, and c, and you can see that in this problem, a is 2, b is 8, and c is 1. So we're going to take those values, and we're going to plug them in to the quadratic formula. And when we do that, we get the following expression here, and we'll go ahead and simplify. So we have negative 8 plus or minus the square root of 64 minus 8, all divided by 4. And 64 minus 8 is 56. And then we need to simplify the radical there. So we need to know that 56 is 4 times 14. And the square root of 4 is 2. And finally, we can reduce this by canceling the common factor. We have a factor of 2 in each of these numbers. So if we cancel that common factor of 2 there, we're going to get negative 4 plus or minus the square root of 14 divided by 2. And these are our two answers. Now, oftentimes when you're expressing these answers, you'll want to write them separately. So this would be negative 4 plus the square root of 14 divided by 2, or negative 4 minus the square root of 14 divided by 2. And you could plug these into a calculator to get a decimal approximation, but again, it's the exact answer that we are prioritizing here. In our next example, we have a radical involved in our equation, and in this case, the radical is a square root. And one thing you want to do when solving equations like this, if you can, is go ahead and isolate the radical. So notice that if I subtract 1 from both sides, this will get the radical all by itself. And then we want to get rid of the radical. And we can do this by squaring both sides. So I'm going to square the left side and square the right side. And when you square the square root, those cancel out. So we just get 5 minus x. And on the right-hand side, remember when you square x minus 3, you have to FOIL that. And when you multiply that out, you should end up with this trinomial. And we should notice that what we have here is a quadratic equation. So I'm going to set it equal to 0, just like we did in previous problems. And I'll go ahead and factor. The factoring here is, once again, relatively simple. And after I set each of those factors equal to 0, we will get 2 solutions, positive 4 or positive 1. Now, one thing you need to know is that anytime you square both sides, you must check your answers. So I'm going to go ahead and do that now. So I need to know, is x equals 4 actually a solution? So to check this, we need to plug x equals 4 into the original equation. And if we do that, we get the square root of 5 minus 4 plus 1 is equal to 4 minus 2. And that's the square root of 1 plus 1 is equal to 2. And that says 1 plus 1 equals 2, and that is correct. And then we need to check x equals 1. And when I plug 1 into the equation, we get the square root of 5 minus 1 plus 1 is equal to 1 minus 2. And that's the square root of 4 plus 1 equals negative 1. And that says 2 plus 1 equals negative 1. And this, of course, is false. So you can see that x equals 1 is actually not a solution. It fails. And once again, we call this an extraneous solution. So our only answer here is x equals 4. This equation involves a higher power of x. There are a couple of ways to approach this problem. I'm going to take a basic approach here. Notice that this has the structure of a quadratic equation. And so we can go ahead and try factoring. We just have to adjust our factors a little bit. So to get x to the 6th power, we would have to have x to the 3rd power times x to the 3rd power. And then for negative 3, we need negative 3 and positive 1. And I want you to notice that when you multiply this out, if you multiply the outside terms and the inside terms, you get positive 1x cubed and negative 3x cubed, which gives us a total of negative 2x cubed, which is what we were trying to get in the middle there. So this is the correct factorization. So now we can go ahead and move forward by setting each of these factors equal to 0. So in the first factor, we have x cubed minus 3 equals 0. We can add 3 to both sides, and this gives us x to the 3rd power is equal to 3. And then to solve for x, we need to cancel the 3rd power. And to do that, we take a 3rd root. So we take the cube root of both sides, and we get x is equal to the cube root of 3. So this is one answer. And for the other equation, we can solve it in a similar way. We subtract 1 from both sides. We get x cubed is equal to negative 1. And then we take the cube root of both sides once again. And we get x is equal to the cube root of negative 1 is actually negative 1. And those are our 2 solutions. This next example is a lot like the last one, but it doesn't look very similar. So the key concept here is you have to understand how radicals work. So think about the fourth root of x. Remember, the fourth root of x is the same as x to the 1/4 power. So I want you to notice that if you had the fourth root of x multiplied by the fourth root of x, this would be x to the 1/4 times x to the 1/4. And using properties of exponents, we can add those exponents together. And x to the 1/4 plus 1/4 would be x to the 1/2, which of course is equal to the square root of x. So my main point here is that if you multiply the fourth root of x by itself, you get the square root of x. We can use that when factoring here. So when you're trying to think about how are you going to get the square root of x, we're going to use the fourth root of x and the fourth root of x. And then we just need to focus on this number here. How do you get -4? Well, the factors that are going to work there will be -4 and +1. And once again, if you multiply out the outside terms and the inside terms, you'll notice that you get -3 times the fourth root of x. So now what we can do is we can set each of these factors equal to 0. And here we're going to have the fourth root of x is equal to 4. And to solve this, what I'm going to do here is raise both sides to the fourth power because I'm trying to cancel the fourth root. And 4 to the fourth power is 256. And then for the other one, it's a little bit tricky, but notice that if you subtract 1 from both sides, you get the fourth root of x is equal to -1. This is actually not possible using real numbers. Okay? The fourth root of a number, that x value has to always be a positive number, but the fourth root of that number is never going to be negative. So that's not possible. Right, so you have to be kind of careful there. So our only solution here is 256. Okay, so now we'll talk about absolute value equations. This is kind of a special case. So we need to review when you have the absolute value of something is equal to, in this case, +8. You need to remember that there are two possibilities for this. In order for the absolute value to equal +8, the number inside here can either be +8 or it can be -8. So you get two equations from this. One possibility is 5x minus 3 could be equal to 8, or the other possibility is 5x minus 3 could be equal to -8. And then we just need to solve each of these. So these are both very simple linear equations. So the first answer here is going to be 11/5. And when we solve the other one, we're going to get -1. So we have two possible solutions there. Now our final example is probably the most theoretical and maybe the most confusing one in this whole set. We have an equation here involving several variables, and we're asked to solve for the variable t. Now I want you to notice we have a t squared here and we have a t here. So this equation is basically a quadratic equation when you're looking at the variable t. To solve a quadratic equation, we like to set it equal to 0. So I'm going to subtract h from both sides, which will give us 0 equals 1/2 GT squared plus V naught times T minus H. Now, real quick here, this variable looks like V sub 0, which is actually correct. You can say it that way. But most people will pronounce that as V naught. Okay? It's a little bit easier to say in that way. So what we have now is a quadratic equation, and we can use the quadratic formula to solve for t. This number here is our coefficient a, this number is our coefficient b, and this number is our coefficient c, and we can plug those into the quadratic formula, which in this case will be t equals, and then negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. And if we plug that in, we're going to get negative v naught plus or minus the square root of v naught squared minus 4 times 1/2 g times negative h, all divided by 2 times 1/2 g. And then we just need to simplify our answer here. So we have negative v naught plus or minus the square root of v naught squared. And here we have a negative times a negative is a positive. 4 times 1/2 is 2, so we have 2gh. All divided by g. And there are 2 answers here for t. Okay, and notice that your answer contains the other variables because we don't know the values of those other variables. Okay, so this should prepare you for your assignment in this section. However, I would say that these examples may not be comprehensive in terms of reviewing all the various techniques of solving equations that you learn in an intermediate algebra course, but this should definitely help get you started.